Okay, so we can officially start now.
Okay, sure.
Okay, well, hi, and welcome for joining. You can start by introducing yourself a little bit, and maybe we can answer a few of the questions that were asked in the beginning, and then get to the code.
Yeah, sure. Okay.
So, yeah, do you want to start introducing yourself?
Okay. My name is Omama Khan, and I am a programmer as a beginner. I am learning. I'm final year student of BS Computer Science.
Nice. Um, and you're graduating, right? Or you just
Yes,
graduated?
I'll be graduated after a few months.
Nice, congratulations. Um,
Thank you.
and then we can answer a few of the questions. So we had a few questions. I was asked, what is if Leetcode is actually helpful? So has it been helpful for you? What do you think?
Actually, because of your reference, I opened Leetcode for the first time, and it is a pretty good website because I am like new to these interview questions about programming and stuff like that. So I really like that website as someone who opened it for the first time.
Mhm. Nice. Yeah, I think it was really helpful for me too. Especially it has a lot of like company specific uh, Leetcode challenges as well, or algorithm challenges. If someone upgrades to that category, that will be very helpful. And then we also had question on. So we were solving an algorithm on merging two sorted linked lists, and I think we had a question asking if blockchains can be categorized as a singly linked list. Was that the question? I think
Yeah,
maybe
it
that's
was.
the question.
Yeah, it was actually that if the blockchain and linked list is the same thing.
Okay.
So the answer is like the linked list is like a long linear list of nodes.
Mm-hmm.
And the blockchain is like a tree. This is the first difference, and the second is linked list always has the address to the next node.
Uh huh.
And since blockchain is a green-like structure, so it always has the address to the previous node.
Mm-hmm.
It's like expanded down and expanding in the depth.
Uh huh. The depth of the list.
So yeah, because of that difference, it is not the same as linked list.
Oh, interesting. And then we have one more question. Let me see.
Yeah, it was about. I also got a question
Yeah.
about how many projects do I have in my CV.
Uh huh. Yeah.
So currently, I am as a final year student. I am working on my first final project, and that will be the first project in my CV, which is actually amazing project about. It is in Python, and it is about data mining and like scientific articles, research based system.
Nice. That's great. Um,
That's all. That I
yeah, that's awesome. I don't know if I'm supposed to answer that question too, but yeah,
Yes, sir.
I think when you get started, you're gonna like the number of projects that you have in your portfolio or in your CV is gonna just like stack up real quickly. Because I started with like just three from my boot camp, kind of like a little here and there. But when I started getting my professional projects, it kind of like um, increased super rapidly because you just like get a lot of projects. Okay, so we can start on the code.
Yes.
Um,
Ready?
yeah, so do you want to kind of like talk about what the algorithm is that we're solving today?
Yeah, the algorithm is actually very interesting. It's about like we have two sorted lists, and we have to merge them, keeping them sorted. Like the list is uh, if the first list has values like 1, 2, 3, and the next has 1, 3, 5. So it should be like 1, 1, 2, 3, 4, 5, like that. It will be merged but in a sorted way.
Yeah, so I'm just writing what you said. So when we merge it, it's gonna be 1, 2, and then, well, let's say this was 4.
1, 1, yeah.
2, 3, and 4 and 5. Okay, so
And you missed the one after
oh yeah,
the first one. We have to include the repeated values also. We
yeah.
cannot skip them.
Okay, so what's the first step that we have to take?
Okay, so it is divided in like 3 steps. We have to like the order, the structure of linked list works like every node points towards the next address where the next node is where the next value is stored in the computer.
Uh-huh.
So the way this algorithm will work is the same. We will take the first value of the both lists, like in the first step we will compare 1 and 1, and we will see which one of them is smaller. Which one is the smaller will be placed in a new linked list, and we will keep comparing them till one of the lists finishes first or later.
Yeah.
The first step is to compare the both. Yeah.
Go ahead.
Yeah. So in the first step, we will compare both lists and compare the first elements of both lists, the first node they have. And the smaller one will be stored in the new list. And in the second step, we will see that if any of these lists is sorted and finishes first, means the second list has nothing else to compare with. So that value will be stored at the end of the new list.
Okay, that sounds great for the summary of kind of the pseudocode. So if you want to start kind of typing out the code, the first thing we need is to define a linked list, or actually the list node. So we need to define the node of the linked list so that we can start creating the nodes.
Yes.
So how do you define a node?
We define it like as a function. Function is node.
Okay, I'm gonna start typing. So function list node, and it has a value.
And
Node.
yes.
And then what are the kind of like the
Like
properties?
there is a keyword use this. The keyword this actually corresponds to the value we are pointing at the moment.
Mm-hmm.
So this value will be the value.
Okay, and then each node also has a next node, which at the beginning is going to be null, right?
Yes. It's cool because in the linked lists there are like a node is like a box that has two portions. The first is header, and next is has the address of the next head value.
Okay, so we're at 6%. Let me open this to you. This is probably better lighting. Yeah. So now we have our node created in a function, so we can start using it. So we can write our function that's doing the merging, right?
Yeah.
Okay. So I'll write the function. Is the mouse here? Now it's basically gonna write everything inside this function, right?
Okay.
So what is the first thing that we want to do in this function?
Yeah, first we have to define we have to create the first basic head on which we will start building our new list, new linked list.
What do you mean?
The first head of the new linked list.
Okay.
Okay, come on, this.
Okay, I see. Yeah, I understand what you're saying now. So we want to define a dummy list, right?
Yes, we have to create a dummy list upon which we will build our resultant list after merging.
So to create a dummy list, what are we gonna define in our variable?
First the head, the head of this list, dummy list, which will be equal to the new node, which will point towards actually the list node.
And we can just give it a value. Okay. And next
we will set the position of the current node to the dummy head.
So we say the current node is at the dummy head.
Because at the moment we don't have a new, the next node, so we'll just point towards the dummy head.
Okay. So what do we do then next?
Yeah, now we have to start the comparison of both lists. So we will start our to make sure that we keep on reading the both lists till one of them or both of them end. We will start our while loop.
So we do a while loop, and what's the condition inside the while loop?
Till L1, the first list is not equal to null.
So L1, or actually L1 is not equal to null.
And L2 is not equal to null.
And we want it to be and because we don't, whenever we hit the end of either the smaller one, we want to stop looping through both of them. So that's when we want to stop, because they are already sorted. So when we stop going through, or when we hit the end of the smaller linked list, that's when we know the rest of the other one is already gonna be sorted.
Yeah.
So we can just stop looping through and just add whatever is left to the end of the new list, right?
Yeah.
Okay.
So we have started the while loop. Till this point, we have made sure that the list is that the comparison will keep going. Yeah. Now we will actually start the if statements of the code, and if the now we are testing that if the value of the first list is less than the value of second list, where will it go? So it's less than the value of second list. Then we will point the current node to L1. Like we are bringing this smaller value inside the new linked list by pointing the current node towards them. Okay. So L1 is equal to next. The concept here of this line is actually the linked list works in a pattern where you, like when you're bringing something in the list, now the node of that new element will point towards the next. So we make sure to store the next every time we create or we bring a new node into the list.
Okay. So, and then let me clarify something here. So we are setting the current node to the dummy head, and then in the first, whenever we hit like one of, okay, so we were over here. So we have the else condition, right?
Yeah, now we have the else condition, because if L1 is not less than L2, then you have to point the current node towards L2. Means the value of L2 is smaller, and you have to bring L2 into the linked list instead of L1.
And then we also set L2 to L2 dot next, so that we can step forward.
Yeah.
Alright, and then what do we do next?
Yeah, inside the while loop, you have to make sure that once you bring a node into the linked list, the node keeps the actual, the address of the nodes keeps shifting towards next, because we don't want to overwrite the same node again and again. So we have to write that current node now pointing toward the next part of the current node.
Okay. So we set the
Current
current
node.
node equals to current node dot next, right?
Yeah, this is fine.
Yeah.
And now this ends the while loop here.
Okay.
And actually, I have the okay. So cut this part because let me think again. What was the next slide today?
Okay. So you know where we are now, right?
I know.
We're at the point that we've stopped, or we've reached the end of the smaller list. So we are ready to figure out which one is not null now, and we basically append the remaining of the one that's not null to the list that we were creating. Okay. Yeah. So how do we do
because that? Okay, at this point, we know that one of the lists, as you said, one of the lists may be shorter than the other. We cannot end the code right here. So we will see that this list is still remaining. Okay. If there's a list remaining, so you will start our if conditions here.
Okay. And what's
if L1 is not null, if L1, the first list has still elements left in it, then we will bring that into the linked list. So we will point the current node to the L1. The next of the next part of the current node to L1. Else, it is current node dot next is equal to L2. If it's not L1,
so if L2 is not null, right?
Yeah.
We do the same thing. Current node dot next equals to L2.
Yeah.
Okay, and then.
And after that, because the requirement is we have to return the list at the end. So we will just keep returning the demi head dot next every time. Because in linked list, the elements can be, we can access the numbers or the values by using the next node, using the next keyword.
Yeah. Okay. All right. So this looks like it should be working now. Let's do. We need to give it an example, but okay, let's give it an example. Let's say L1 is equal to I think we need to give it list dot node, or no, new list node, and then we give it like a value 1, and then L1 dot next equals to 2, L1 dot next. I think there is a mistake in the way I'm defining L1 and L2. Yeah. Let's just, before we do this, next is 3. This would have to be dot next.
Yep.
Dot next. L2, L1 dot next dot next equals to 3. Why is it not
Should
doing?
that be the new list node 2 because you are storing two values in it, or there are two nodes in it?
What do you mean?
The new list node value, the value have written inside the brackets.
Like give it a new list node?
Oh no, the on line 35
Uh-huh.
in the brackets.
Uh-huh. Give it more values here.
What about if there are two values in the node? So what if we put two here?
Let me get something else. Let's Google how we can define linked list. Oh, got it. I got it. We have to do one dot next is equal to new list node two new list node three. Yeah, that's how we're supposed to do it.
Oh, okay. You have to.
Um,
I think I got it. I got it, Aida.
what?
It was actually current node dot next is equal to L1.
I knew it. That's why I kept asking the question there, because it didn't make sense.
Oh, wow. Now what? Should we or like delete this all and record again?
No, it's okay.
I'm so sorry. I skipped it.
It's okay.
I was sending you the diagram and doing everything but looking at the
There you
code.
go. I kept saying something doesn't make sense here. See? Okay. So now we're on the code. And now we don't have any outputs. Why? Oh, I know why. Because we have to do console.log of this.
Oh, sounds good.
There you go. So now I have one, two, which is 1, 1, 2, and then
3, 4, 5. We are missing 3 more values.
but it's giving us just an array.
Wait a second. We don't have. Yeah, we have 2 ones and 2. We don't have 3, 4, 5.
Why is the next after 2 is an array? That's weird.
Where?
Yeah, it's an array. Like, I'm guessing it's just not printing it out, but it's actually there.
Yeah. Is there a limit on how long the output can be printed, or you can
I think so.
you can do that yourself? I mean, by saying that, yeah.
See? Doing 112,
Yeah.
no.
Yeah.
I think
Got
it's
it.
there. I just don't know how else we can show it. But it's there. It's doing the right thing. So like if we do like 1, 2, 3, for example, and then like don't do repeating ones. Let's just not use this one either. Now we're gonna get 1, 2, 3, and the rest.
Okay.
So it's working fine.
Yeah. Can you scroll up for a second? I want to say something that you can do in the video. The mistake I made.
Yeah.
The first thing we missed is because we didn't write before the current node.next. We were just out of nowhere. I suggested to store it in the L1 in current node, which alone didn't mean anything. So we had to store it in the next software. Interesting example.
Oh, do you wanna explain the error that was in the code one more time?
Yeah, the error was, as you said, you concluded in a way better than mine, because you said that we can only say current node dot value or current node dot next, current node dot text. This is how we can describe a linked list. There are two parts. We cannot just say linked list. Either it's the head of the node or the next of the node.
It's either the value or the next. So each linked list has two properties, either the value or the next. So you can either address or point at the value, or grab the value or the next. Okay.
Yeah. Yes.
So that's why when we were just doing current node, it was giving us an error that you cannot set the property of null because current node itself is not defined. So that was the issue. Yeah, but besides that, the code is working, and we are
the
getting...
values you gave for the first node as one, for the first list as 1 and 2, and for the second list as 3, 4, and 5. It is giving an array at the end because it is there, but it is like compressed. It is hidden.
Actually, let's try something. So let's go here and try this code in... Okay, finally! Now we can submit. What's the issue?
You didn't.
It's capital L. Okay.
Oh.
Submit. Yay! It worked!
Fine.
Now we know it works. We faced a lot of difficulties. And we can run the code as well and see the result.
Okay.
But it's actually faster than 50% of other whatever results submitted.
Yeah.
There you go. So that's the output. 1, 1, 2, 3, 4, 4. Yay!
This is okay. This is amazing.
We did it.
I like this website.
What?
I love the interface of this website. It's actually great because
Yeah, yeah. You should become a member too.
Yes,
And
I will. After this, I will.
virtual high five. We did it.
Yeah.
Nice. I think we did learn a lot, and it was a really fun session.
Yeah, recording in two places.
Yeah. Awesome. So
Yes.
yeah, that's it. Thank you for joining. I'm glad.
Welcome and thank you for this opportunity.
Yeah,
I'm glad that I could join you for this.
yeah, yeah. I'm so happy we finally made it work. I know with your final projects, and I just started a new project, like a new job too, and like with everything, all of that, we finally found a time that we were both kind of a little having calmer lives.
Yeah,
And
because you are like it's your morning and night by night.
yeah, and I think if I close the windows, I don't know where's the light coming from because I can't see myself. Yeah, I still can't see myself, but it's okay. All right. Well, yeah. Thank you. And I guess we can end the session here and then talk
Yeah, sure.
with each other again after. I know it's your night and it's like 1 a.m. almost.
Yeah, sure, inshallah. And thank you so much, Aida.
You're welcome.
I really enjoyed this video.
It was great. Thank you.
Bye.
Bye. Okay, so I'm gonna